Welcome everyone to another video here, world record-breaking Linux distribution work. Basically we already support 31 CPU architectures. That is kind of a little bit cheating, but it also how other Linux distributions, namely we support like 32-bit ARM in 3 flavors and stuff, but Debian and stuff do that the same way for this statically compiled optimized stuff for little endian, big endian, ARM version 5, 6, 7. And so on. So yeah, basically it is, we have a couple of, like we support 31 and theoretically maybe some more build, but like this list is what we currently build. And so let's do one more thing. I basically just want to like trying to find a easy way, easy low-hanging fruit to support even more. And I think that Renesas has a chance. I quickly looked into that like 10 minutes before this live stream. Like, should we add tile? I mean, long arch is a little bit. So by the way, is that potentially, is it with double O, right? And so it is. But I also see Sky. There are a couple of others that might be easy, but see Sky is also some, yeah, Chinese whatever. I'm not the most interested in like obscure Chinese whatever stuff. So I'm also. Yeah, so let's try this Renesas. The only thing is it unfortunately was removed from the Linux kernel recently, but that doesn't stop us from supporting the previous. So let's see. So let's do I have already architecture? So it's another. So I added that already. Let's find. So that would be uclibc. So let's add that here. So that do we need that? Do I need to add uclibc here? Uclibc. How did I previously? I mean, I don't necessarily need that here. It would, if there is no glibc support, default to uclibc. I just scan this list there for how I usually. So yeah, AVR32, I also suffix by that, so maybe to keep the scheme here, I'm gonna probably do that. Build all for, what was my syntax? I think H8 3000 uclibc, I've seen if this explodes. So yeah, basically while we do that, also I will then finally build all the ISOs. I had that previously built, I just wiped them today. Obviously, I will rebuild that just with the latest compiler and everything. Okay, that did not went that well. Unrecognized command line option min32. So we only need the headers. So what's going on there? By the way, what I usually do, because data may not necessarily auto-track all the packages, uclibc. I usually use a chance for a quick win-win of checking are there new versions. Oh wait a second, actually the freaking are. Like this is a major win-win, right? So theoretically update package uclibc one. I probably so for such important packages, so they were all, I mean they're all 22, not that old. Which other uclibc? So we should test build that to check for build errors, and we otherwise are open risk, of course. So that would be open risk uclibc. Oh wait, I deleted that, right? So yeah, I mean it's a little bit. That is the thing of the live stream, right? I would sit here alone or with my co-workers here, except I'm in the home office. So usually I would sit kinda alone-ish at home or the office or whatever, but you can also share this stuff together live on YouTube, right? So I'm only test building open risk now because that is another reference. Architecture, so at least the header instruction works. So the other stuff like takes 10 minutes on this Threadripper Epic Ryzen. Yeah, it's probably good enough. I could even untest it. So I should also, as I like to do so much, pro tip, everything that you will otherwise forget to your to-do list management like GitHub, or additionally, of course, we have a GitHub issue tracking, but all the small stuff, let data auto update, like arch specific by default or packages or something. Did I update already? No, I didn't. So let's quickly test the other two. I only do that a little bit professional. I'm not always doing that. It was if it's like, if I find like some random junk like Xsnow or stuff, I'm of others people's attic and basement projects. It's like a kind of pass, which pass. Okay. Actually, okay, this might not be a regression. This might just have auto reconfigured. It might have been. Oh wait, I did this wrong. It's probably just configuration updated to the new version, kconfig-like version. So that is why this failed. Probably just all the directories and stuff not found. Let's see. This is why this rebuilds now for 23.1. Cheers. So just a little bit extra sanity testing. Actually, like let's hope they didn't just. So this uclibc header stuff already extracted. And then 2. And then we have enough CPU cycles. We can just let this build, of course, to test in the background. Use a little bit multitasking. Does this new stuff actually, like for open risk, freaking build TM. You know what? Let's even clean that. It should be fine. Famous last words, right? But it's not worse. Like if there's something missing, some hiccup and stuff, let's just this 30 seconds rebuild it from scratch just because. Okay, so actually, did I probably not commit that? So that can build in the background, and then our H8.3. It might be something trivial like directory naming. It might be that they call that differently or stuff, but that is what we're here for, right? Also, why we do this exotic stuff, you might wonder, why do we do this? Just supporting. It's, of course, a little bit not very sexy to call. We support 31 CPU architectures, 32 sons, of course, like power to the 2. So, binary and stuff. So let's see what's going on there. Might simply be some naming thing. Why do we have 2 there? Ah, darn, I have done this wrong. Do I really have both of them there? Whatever going on there. No, it's a bit, I should delete those. So H. Oh wait, did I configure that? Oh wait, this is also wrong. Yeah, nothing like after some business events and stuff, getting back to code. Just wiping all the stuff that we built accidentally, so we don't constantly confuse the stuff. So a little cleanup so that it's still bootstrapping. And then what's going on here? It's of course a little bit ironic. You might question the viability of doing that, but it's just fun, right? Just for fun, just as a hobby. Why not support this? There might be plenty of people coming back who, for the next years, even Lego Mindstorms or whatever that was used in, and certainly all those embedded gears and stuff. And then it's of course helping those people who reverse engineer or repurpose DIY stuff. So H8.3, so that's actually named like that. Why does it build for others but not for this. Maybe this needs some MN32. So probably it needs some bootstrap hack. It looks on first glance that it's using target. Yeah, so it's using target and options when we only want to generate the headers. So theoretically we could also easily support CRIS. I'm not sure if we said at least had some wider access, also scanner and camera or whatever. So yeah, so I comment this out, but of course we need this. So the way we do this is we only disable these options. Also actually we should check if that builds though. Yeah, okay, I don't want to mess up my system now with clobbering random headers all over the place. So we will only apply this for the bootstrap stage, right, for the header extraction. So the name will be, let's start with hotfix H8 patch cross 0. We have special naming conventions for this codeless stuff. Let's see if we have this for other architectures. So, no, interesting. So I mean, usually you don't necessarily need that. For most architectures, you don't have such crazy options, and so mostly we're probably getting away with that, like for PowerPC and Spark and OpenRISC that don't have options like that. Okay, so this so far works because so the thing is, it's a chicken and egg problem, right? To build a cross compiler, we need the headers, and we have the similar issue with glibc, right? So we similarly hack up and patch glibc to not require compiler. Just realize we want maximum performance and no tempfs size limit. So yeah, stuff is building. I wonder theoretically, I mean, I just increase it to 32 now. I'm already wondering, because CRIS was, do we have CRIS here? Oh no, we don't have CRIS here. CRIS should be long supported though. uclibc, I think it's also removed from the Linux kernel. CRIS, let's maybe, I mean, it would make it 33, but maybe it's not bad to have a backup in case some stuff starts to fail. And with the removal of the Linux kernel, we will simply overlay that so that we will simply use a slightly older Linux kernel. What's going on there? Something 5.1. Was it so long ago removed? CRIS. So once upon a time it was in there. What date was that? 2000, as far back as 2016. Here was discussions on 266. No, thank you very much. Probably should check. I mean, it's funny that was a relatively Linux-friendly company and stuff, and then it's removed because that was still in there. That's not that old. Which did I use this one, right? So 5.4 probably wasn't. So there are also some architectures in there that don't even have GCC support. So theoretically, we could support, I think it's hexagon, but that only has clang support, at least upstream. Oh, that is already removed there. Which one was it? It's still in there though. That is 414. The question is which, so usually I use a shortcut of copying that from another architecture. So, for example, Blackfin, we could first check before we randomly try that. Blackfin was also removed. Nice DSP architecture. 416. Does that not log for? Okay, 416 might still be. Let's try that. And otherwise, we can just edit that later to another version. Where did I build that? Is it not here? Here we build. So that stuff is still building. That is theoretically, do we need? Oh wow, GCC can't resolve. What the heck? So much to that. What's going on there? Static object libgcc. Yeah, that is always super annoying. Can't resolve. What's going on there? What I usually do, I mean, I'm certainly not usually fixing upstream GCC companies, like if Renesas, was it Renesas? Yes, if Renesas want us to fix that. So this has not that already. Then let's use 14. And so yeah, at least major, the usual win-win is also like, if you still question why I do this nonsense like supporting Spark, 32-bit Spark and stuff, at least we found for our embedded users that the uclibc wasn't up to date. And that's the thing, right? If you don't, even if you have embedded projects, you don't always usually check that. So it's basically live streaming my, let's check what's new, what we see and stuff. Often fixing some surrounding stuff. So here, the question is not really sure what it's trying to do there. Obviously, we would need to check the sources. But even the thing is with all those monstrosities of build systems, it might take a while to actually. Oh wait, does it? Did this actually build now? Actually, that is funny. It is possible that it piped that to some files. So that is, yeah, the usual build system limitations. That is fun. If they probably doesn't copy and paste like that. No. For 14, did we not check for 14? Or do they not have a dev config? Oh, they don't have a dev config that. So then maybe there would even be possible to use 16. Let's check that. Ah, typo. Maybe I call it a day then for this Renesas if this CRIS stuff does just build. I only wonder what is our code doing there. So that is source Linux header. Oh, this is CRIS, you see? Just not this dev config. I wonder if we only fall back to that if we don't have our own config template stuff. That might be possible. Yeah, it's yeah. Okay, so let's simply do that. What do we have for AVR32? Probably that one might be. Yeah, actually, that there is a little. Yeah, let's copy that one. Yeah, to do is good. Just some. That's probably fine, at least for quick test. Fingers crossed. So yeah, then let's switch this. I mean, who cares about those Renesas, right? The point was just to have 32. Good that we worked on a backup. Okay, that Linux header is extracted via uclibc. Same thing as we just patched for Renesas. Might be enough. And then I probably will eventually do some more surprises. I can announce this already for the true fans, sharing, liking, subscribing, and hanging out together here. I will probably package, just for the fun of it, or at least try, the vintage and retro, but truly significant, important, and widely used, like previously widely used, but of course long deprecated, AMD 29K, 29, 2.9, 20, yeah, 29K. The AMD RISC, like from the end of the 80s, widely used, popular RISC architecture, AMD AM29K, and once upon a time there was GCC support, of course, decade long deleted. But I will probably, like, not today, but eventually I will add support for this. We have theoretically already, well, theoretically not as regularly used, but theoretically support for AVR 8-bit microprocessor. Like, why not use this amazing build system, like amazing codeless and nicely structured build system for your microcontroller stuff? So, and just for the historic completeness, I added this already to the to-do prior to this video. So share, like, and subscribe if you want to see AM29K and Intel i960 Resurrection. I will probably try that later this year, you know, the usual stuff like let's make a live stream, just because doing tech together. Maybe the summer or stuff, I hope it's not that much work, maybe in the afternoon, like basically finding the sources, patching up. It probably will not compile with modern compiler, like patching around a little bit. But also for the next years, like not this year, but like the next 5 or 10 years eventually, like big plans on this YouTube channel, right? Eventually either get some hardware with that, like some from eBay Vintage Retro, if it's a laser printer or car MCU and stuff, or just get some IC, unused, new old stock, and put this on a breadboard and power that up with maybe even some open source interface explorer. Like it's amazing. I supported that Kickstarter, the Glasgow Interface Explorer. I hope it ships this year. Maybe we can just hook up CPUs there to the bus and use this. I'm also, depending on whether it has enough address lines, but like using other, like interfacing this with either the Glasgow Interface Explorer or other FPGA boards and stuff, like basically implementing other memory and bus stuff to run such CPUs for testing, testing or cross compilers then. So yeah, nice last minute unexpected uclibc updates. So yeah, this stuff does not as easily just build. So I mean, theoretically, should we try an older compiler? Do we have other compiler? Probably. Let's see what other. I could quickly test other Benutil and like older, like last year's. Off package GCC. Okay, we have Blackfin. That might be. How much older is that? Oops. 3.9. It's probably worth a try. Blackfin package. Like, we are still waiting for like other stuff to just compile for the test. So GCC2 H8 package. Yeah. Oh wait, why? Wrong. H8 3000 300 catch. Oops. And let's give that a try. Maybe we are lucky. And it's also protop, right? If so, my recurrent protop is analyze stuff really to the core of the problem, but it's otherwise like if you don't need the latest and greatest version and don't need to analyze that, because like if it's not like a NASA or ESA satellite like mission critical automotive self-driving car project and stuff, then it's low-hanging fruit first and then deep analysis. It's probably a fair tip of how to shortcut stuff. Okay, this has the same. So then it might also, I mean, besides there might be general brokenness. I really wonder where all the spam shit is always coming from. I really wonder how YouTube can be that bad at command moderation. The future 2023, the future is AI, but Google of all companies can't even filter such obvious messages. So one more try and then also this also breaks. Also wait a second, this is just CMake, like CMake, who cares what build was it? It's open risk. Yeah, I need to find a solution for this. This doesn't scale like that. Touch open risk. Like basically you don't need that in system. We need that for cross compiling, but what's going on there is not supported. So maybe they removed CRIS from GCC. What's the best without typo? Mm. 2020 something, whatever. Let's try the same trick there. Actually, you know what? Let's be NCP to CRIS package. And do we have maybe a binutils? AVRN properties, it's not, but we could use that overlay as a simple example of how much is needed. But yeah, probably that needs more of an analysis of, does it start to compile more? But yeah, at least in 30 minutes time we majorly updated uclibc. For all other architectures it certainly is a huge win of non-mainstream C library. And I mean, I could try to Google that. That is H2. Of course. H3000. Super many. Like, you know that you do hardcore non-mainstream stuff if Google only has 2 results. Welcome there. Releasing I showed probably some mainstream, less technical videos, wider audience. Yeah, I did failing gigabytes, gigabytes. Totally will do that. It's just I want to release T2 Linux, and these are certainly like uclibc updates. Totally get that. I'm certainly aware of that. I'm certainly aware that product review videos sell better on YouTube and so on, but we are not a sellout. So whatever's going on there exactly. What is a little bit strange is that it failed so similarly for both architectures. But yeah, probably there are also enough mainstream channels, right? Really cool, have special use case in mind with architecture. Not with this architecture, I just want to support 32. It looks like CRIS is an easier target here. Oh, we're also building CRIS wrong. But certainly Intel i960 and AMD 29K certainly much more usable and historically significant. I basically want, we will also do microkernels, so it's basically just in 30-minute YouTube tech entertainment and stress testing my Linux build system environment stuff here. Config. Parallel here, 32, let's certainly speed some stuff up. And so yeah, CRIS, let's power PC, let's give that a quick try. How much patches? Yeah, tiny bit patches here. 2H83 bin utils, and then probably even a little bit older. Let's see if we can H3. Like just okay, that is also I even have this assertion failure here. I should actually theoretically test if they fix that eventually upstream. So this will be another thing. Do I have? Could be that just because. And let's try to make this even a little bit. Oops, even a little bit older. Let's hope the patches still apply. A3 package. Of course, we don't need the poor PC thing, but we need, theoretically, we need the LD. Oops. LD glob patch theoretically, and H3. Let's see what happens. But yeah, probably good that we started a second alternative here. So CRIS appears to be much easier, apparently. And then we obviously go for that. We could already change that so that that becomes our 32nd and H8 add this back to the to-do. Where did I have that previously? Yeah, slightly moved that, but in core total scheme of things not really relevant. So yeah, this may or may not fix something. I don't have the highest hopes, but let's see. Maybe it still works, maybe it doesn't. But this year will definitely, I mean, maybe, wait, oh no, this is still building. I was just optical illusion of leaning back. But this year will be definitely, I mean, maybe I will live stream a little bit less this year because need to be a little bit more commercial successful. But we will do other, we will also do a little bit less Linux things this year. A little bit less, still a lot probably, but I will definitely do, oh, this is interesting. The arrow changed. Difference of, oh wait, it might actually be different sections is not supported. Hold on. Is it possible? Oh no, it is possible that this is position independent stuff. I should have checked. So that might, let's not build with that obviously. Let's see, and then maybe we don't even need this Benutils and GCC overlay. Just a long shot. I should have lab pro tip. I should have spent half a minute of actually reading the error message. So yeah, this year microkernel. I'm not sure how much microkernel we will do. The microkernel stuff we will, of course, we will do low level stuff, right? We will not be writing a whole microkernel in a year, unless you share like subscribe and I can pay my whole salary of YouTube microkernel work. But realistically that will not happen. We will however do lots of Hello World stuff, so just to gather some experience. I mean, I have of course experience with all the low level stuff from 25 years of Linux, of early boot system interfacing stuff, of MIPS, ARCs, SGO2, this is even freaking built. You know what, let's wipe that and let's try without this GCC overlay and Benutils overlay. So this was either forced pi or stack smashing protector. Most likely stack smashing protector, but maybe both. What was it? HA3 and how many package overlays do we have there already? Ah, those two. Okay, let's. So subversion will still record this information. So let's rename that so that T2 does not use it, and let's rebuild that. And let's see if it's loot. So I'm not delusional or stuff. So not the microkernel in 1 year, but low level. So but there will be like maybe once a month. Of course, other stuff, right? Like every other day or so, some T2 Linux maintenance of maybe KiCad updates or Blender test builds. So we will continue to maintain our T2 as an amazing enterprise and developer ready Linux distribution and supporting all the crazy architectures. But like, let's say, like maybe in January we will do low-level RISC stuff, like maybe in QEMU so that you can run it at home. I also have here still this mostly unused ESP RISC-V based 32-bit RISC-V based ESP. So 1 month, like basically a week, every month a weekend project of Spark, early user space, bootloader kind of stuff, RISC-V, and so on. Maybe like doing 4, like maybe getting an Hello World loaded on an SG Octane, something useful, right? So that would be MIPS, maybe Spark, maybe RISC-V, maybe x86, something like that. And we will not do all, like maybe I realistically target, like let's target 4 maybe, by the way, did this build? Actually, this build. So this error was somehow related to stack smashing corrector pi. Good to know. Which, by the way, we probably also want to disable that for CRIS. So then microkernel. And then some hello world microkernel stuff together with this hello world stuff. So I'm not targeting, when I say once a month, I'm not targeting every month one hello world. I just said 4, so like 4 hello world things for x86, RISC-V, ARM, and RISC-V or so. And then also the other months, so that every month we do one major step, like interrupt handling, memory management, and other stuff. And also I definitely want some kind of low-level compiler thing to have some extremely minimal, I always said this, like supporting 90% of features, or like 80% of features with 10%. Like usually I say 90-10, it makes, I really want to target like 10% code size. Yes, that will not have all the features of GCC and not all the features of the Linux kernel, but my ultimate target goal would be 90% or 80% of the features with like 10% or less code. And that also means like certainly not using C, using some kind of language that is significantly more expression rich than C. There are certainly enough BSD and GPL Linux kernels and BSD kernels out there in C. And because it makes no sense, neither my or nobody's time is worth manually managing strings and other nonsense, right? So even C++ is, in my opinion, the potential of 10 times the efficiency of code to like expressing low-level stuff with 10 times the lines of code. So that's kind of the goal. We will see how far we go. And so this also means I'm not targeting AMD GPU or like latest RDNA 2. I'm not crazy. This is millions of lines of code in the Linux kernel Mesa. That also means in this context supporting some vintage code. I 2 or 3 years ago did some vintage stuff on S3 Verge and Voodoo. And so that means while the ultimate target of this microkernel stuff will be also potentially supporting modern stuff, but ultimately I also want them through the example, and I'm totally aware that the modern stuff is so complex. So in the context of presenting something that I also want to have some fun, right? And you should learn something. So using some kind of S3 Verge Voodoo or similar kind of like early ATI, maybe even early NVIDIA, we will see, and have a like real-time microkernel thing doing 3D stuff, at least on a vintage thing, and then we will see maybe even later Intel i950, so like maybe 15-year-old MacBook, that certainly should be possible, and later more modern stuff. Maybe, who knows, maybe even given that the Asahi Apple AGX, and that's the crazy stuff, right? Maybe the reverse engineered Apple AGX stuff is way easier to work with. So maybe even, who knows, maybe even in 24 months time, maybe even a microkernel thing running on Apple AGX silicon. We will see. So what's going on here? So this might be a similar thing because we probably have SSP, and I wouldn't be surprised if this is a similar build error. And so then this would make the 33 architecture, of course, just destroying my power of 2 thing. But nothing to have. It's obviously good to have some headroom of, certainly not want to be a primary maintainer of GCC and binutils stuff here. Having some headroom of not, if like one thing breaks, yeah, stack guard. So yeah, this is stack smashing. We probably want to, so yeah, this was my guess, and of course it is like that. So config, what was it, CRIS probably, right? SSP and beta no pi, and so oops, wrong control C in the wrong window, and let's update our build all driver to disable that for so we have this basically for a lot. We also don't have LTO. We could basically make here 2 entries. Where do we like our alpha? Yeah, so for now we could share that here with alpha, CRIS and H8 unlike family of those, and then later split this. By the way, do we have QEMU? QEMU for testing. We have QEMU CRIS and H. Okay, this we don't have, so that would be instantly splitting that. Just checking comments and stream links and stuff and drop frames. Splitting this after all, so because we want QEMU, so we have QEMU here. Do we have full system QEMU system? We have good. Do we have this for alpha QEMU system? I think we have that, right? Yeah, we have that. So that is why we split that here, and then we can QEMU system. Okay, we don't have that both. What was it? CRIS, right? No, not CRIS. H. I try to keep this sorted. ABC. H8 today. I didn't copy that. H83000. And yeah, awesome. I mean, total win-win, right? For all those haters of like, why do I waste my time? Is hey, we updated. It's not a waste of time if we update major components like uclibc for all the other OpenRISC and other uclibc using stuff, plus some other slightly vintage and obscure CPU architectures, because why not? People who want to repurpose stuff for their DIY project will love it, and that is how we certainly grow our use base too, and use base and YouTube membership stuff. And that was Pi and SSP. And this is what we continue to call a win-win here, live on this channel. It's probably fine. Okay, that is unfortunate. It is crazy that M4 needs stuff like that. That is truly crazy. Oh, we have this for Spark already. Crazy stuff. So yeah, maybe it is the same. So or arch equals, what was it, CRIS, right? Usually I prefer to have that in the desk though. And maybe I need to generalize this stuff. I find it also crazy that GCC doesn't automatically add that. That is like due. Why is that not a thing? I mean, maybe it doesn't fix this, but let's see if it doesn't fix this. Usually it does. I find it also crazy that, I mean, I would expect if GCC generates those GCC miscellaneous library. Okay, this is actually, although it says artificial there, it is, did we disable LTO? Maybe we should try without LTO. Yeah, I would expect that to work, but somehow it doesn't. LTO. Yeah, let's first see if that fixes, because I know companies, and I've seen devices using CRIS, for example, scan. I'm pretty sure they had a scan server, even based on sane scanner access, no easy. Okay, this still doesn't fix this. I think saved spin C. We could check if that together with, but probably not. Arch CRIS. If you're wondering why I randomly try this stuff, that's just from experience that usually stuff like that fixes that. But apparently not in this case. Usually the atomic stuff is also differently named, so maybe there, I mean, it is possible that there is some general configuration marginality in GCC, so maybe we built GCC slightly misconfigured. That is always possible. Let's see how much other stuff builds. So often we have this issue. So if this would be customer project, I would analyze it now, but given that it's only some quick hack. So this is also wow. Where's even the arrow? Alright, this is we built for. So good that we still have alternatives to reach 32 supported architectures, because the stuff the OpenSSL has similar thing here. It is possible that just, is it the same? Yeah, there is CRIS at Compact Exchange. Why is there -T2? There's some strange uclibc final link but value. Maybe it goes away using another CRIS CPU. This is also possible. So I would need to analyze what exactly is going on there. Maybe it needs another CPU with Compact Exchange, and that would get rid of that if we are lucky. What do they have there? Version 3, 8.10. Yeah, we probably want to add optimization options and hope that this goes away with some higher of those potentially. Do we have those already? CRIS. No, we don't. What other stuff did I just YOLO? Was it LTO? I re-enabled, right? So yeah, maybe some new CPU implements this and this magically goes away. And what's going on here? Certainly need to see library. This file is machine dependent, not provided for this. So this is probably this user. And read application of size of incomplete type of user extract. What is going on there? Probably some, I mean, obviously some feature not implemented. Yeah, that doesn't have a user age there. Not really sure what's. Actually, it should support something, shouldn't it? Not sure that is threading related. Has no threads is not set. Has threads. Linux threads. Wonder which feature exactly that is. That is that from regex external. says there's regex though. Somehow there's always something, right? I hope this is running the same. It's building something, though. No, that didn't fix everything. Why did it promise? Does uclibc have? H8 apparently not. Pity. We could, so for this we could check the GCC sources. Let's also remove somewhere. I had here this H83000. So CRIS, maybe that goes away with new CPU architecture. So let's, as one last thing, by the way, did I already remove this from build all internal? Oh yeah, I removed this already. CRIS. So basically we could actually, you know what, let's probably simply like AV. Do we have AVR? Yeah, we have some. Config. What do we even do? And then so yeah, we could theoretically, but this is actually not even necessary. I think we could even remove that from AVR32, to be honest. But what do we have there? We have there V3, V8 and V10 for those. Default is V0. Okay. And then let's like try V10 and see if that fixes that, and hope that supports the most. For this was a typo. So is that, wait a second, did I use tab? No, I didn't. So does it look good? Oh no, there's one more. So the only thing is we will have a full rebuild, so probably I will comment this out until we did the build. let's see if, so let's, oh wait, so wrong. Not sure why I manually edit that. Probably should, maybe there's a typo. I should have run the config proper. Wait, there's also, did I say proper? Okay, so that I didn't have a typo there, and then let's see if that, theoretically we could untouch M4. Oh, darn. But yeah, if you want an amazing open source project and people ask, why does it not support this, that, and so on. Okay, this did not magically fix that. That is sad. So then I need to, I mean, first of all, I should check if that actually has an effect. 10, 18, 20. No, it can't be. Unless the clock is 35. Where is? And so it would be the question: do we correct? Ah, no, we don't use it. I'm so stupid. We didn't use it. That explains the thing. We of course need GCC options 2. Let's copy that from there. Change it to CRIS. Theoretically, we probably could somehow. Is it generic or? So that has some custom YOLOing here. So if that and I guess I had said generic, usually I have generic, then was it MCPU? We should actually check that. March, or actually apparently both work here, so I guess whatever. Let's try that again. Let's still hope for the best. So one quick look to the comments, and also best was a typo. And then let's call it a day. Where do I have if that CRIS opt and then alright, also that's not the case. Nick, long time ago, asked how do we test this. We test this partially in QEMU. I'm continuing previous videos. I'm continuing setting up automated testing, but also I have lots of things in real hardware. Still looking for some of those, and then also community, right? More and more people want to use T2 for their vintage and retro stuff. So yeah, it's adding V10, and that didn't fix it. That is set. Also, is it possible that this is in async save spin unlock? Yeah, it needs more guru mutation. So much too low-hanging fruit of just supporting that, but at least we have updated our uclibc, and Eric says we're being mentioned in some channels that also are technical, but don't know if it's translated into views. Maybe it does. Certainly, we got some RISC-V views right when we were mentioned at Linus Tech Tips and Level 1 Tech. But that's it for this video. As usual, some more attention to detail and work needed. I hope you enjoyed it and learned something, as always don't forget to share, like, and subscribe, and I hope to see you soon for the next fun stuff to come.